We have smartphones, smartwatches, and even smart fridges. But now, from a paper published in the journal Photonics Research, we could be seeing smart glass. Researchers from the University of Wisconsin-Madison created a piece of glass that can mimic machine visual perception, basically how smartphones recognize your face to unlock your device without needing any camera sensors, computer chips, or even a power supply. All the glass needs is a light and tiny imperfections called bubbles within the glass to direct that light appropriately. Right now, it has the capability to tell in real time whether someone has written the number 2 or 8 or any number 1 through 10, even if the numbers are written in different fonts. I reached out to co-author Zhongfu Yu to get the motivation behind such smart technology.
We basically have air bubbles inside. It will scatter the light. And this scattering is not random. It's not arbitrary. It's precise, engineered.
What techniques are you using to make sure that the light is going where it needs to go?
So you start with a number, and you know the answer. And you start with a random location of the air bubbles, and you know it's not going to give you a right result. But you will adjust the bubble's position so that it gives you a little bit better result. And you go through this training iteration process hundreds of thousands of times, and eventually the glass learns to generalize what it sees. So this all is done in a computer simulation. So it's a very expensive simulation, but once it's done and it put into glass, it works forever.
Once you know where the bubbles want to go, how are you getting the bubbles into the glass?
The way to make this kind of three-dimensional structure is go to 3D printing. So you basically build up this glass layer by layer, and we can do a layer fabrication, one layer after another.
How much exactly does this cost to produce? Is this something that's going to be feasibly made in the future?
The material we use are extremely cheap, and also it doesn't limit to glass. You can do it in even liquid, you can do it even in silicon. So there's just a variety of material and fabrication technique and you can choose from. What we want to actually show in this work is that you can use physics to do artificial computing, and you don't necessarily need a digital computer to do that. And I do believe there will be opportunity that can solve practical problems within the practical budget.
What do you and your team want to see this technology being used for? What is the takeaway from this?
Let's say if you have a civilian camera that you want to use to identify yourself, and you don't want it to record what you are doing. If it is internet connected, you really run into risk that some days that this camera can be hacked. And while it does the identification of your face, it might record your life without it letting you know. But this physics-based camera, for example, this glass, you know that it is isolated from the internet. It doesn't use energy, it doesn't pass any data to the internet. So this is a thing that I would think is more secure in terms of as a facial identification as compared to the general camera.
It's not connected to the internet, which is great. Are there any other benefits other than the fact that nobody is stealing my data?
So it's always on, it doesn't use energy. Your battery is out, it's just like your conventional key and lock. It's analog. So if you have a key, you know you're gonna unlock your lock. If you have this piece of glass, you know you will unlock the device behind it, regardless whether it has power, regardless it has an internet. So in a way, it is very, very reliable.
What specifically about the glass are you going to improve?
So we have shown that you can recognize handwritten digit. So that's just a baby step toward a more sophisticated vision task. For example, if you want to recognize a face, we will need to perform much more complicated simulation of the wave propagation inside the glass. So that's what we are trying to do.
Zhongfu Yu there from the University of Wisconsin-Madison. You can find his research published in the journal Photonics Research.
Music in the program is sponsored by Epidemic Sounds, perfect music for audio and video productions.